So
There
is
we
that what
go.
is that what we get graded by? Like by submitting that thingy?
That's just to prove that we did it. So we
Oh,
post it, and then if we did it and it's posted, then we get the 100%.
okay, that makes sense. So
So number 3, mean IQ test score in the United States is 100. 20 randomly selected statistic students took an IQ test, and the mean of their scores was 112. Which of the following statements is true?
I was thinking the first one and the last one are true. 100 is a parameter and
Well, a parameter
112 is statistics.
A parameter is the true number describing the population. A statistic is an estimate of what the parameter is.
yeah, I get this 100.
Mean of their scores.
Yeah, wouldn't 112 be the statistics and system? No?
I believe 112 would be a statistic, and
Yeah, that's
100 is parameter. That's what I think.
yeah,
okay.
I think I agree with that.
All right.
Yeah.
Number 4. Oh, I thought they were gonna say Gotham City, but they said
Yeah.
Rotham City.
Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they're considerably from neighborhood to neighborhood. One neighborhood has very low property value, and another has extremely high. Property taxes are usually roughly proportional to the property values. What type of sample should be collected to gauge the resident responses to a proposed increase in property taxes?
So with this one, I'm thinking it should be the last one, the stratified sample, because when you look at this, they have two samples that they are picking up from. One from the extremely high property values, and the other from the low property values. So it should be stratified.
Okay. Well, that sounds good. You stratified. You divide data into similar groups, and then you take a simple random sample of the groups.
Yeah.
Yeah, sounds about right.
Yeah, so that sounds right.
Question number 5.
When design experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented?
Seems systematic.
Systematic?
That's what I'm thinking. What?
I'm thinking of the last one, the cluster.
You think so? Let me see.
Yeah. Let me go back to the.
Yeah, I'm looking at the notes.
All students in the selected classes.
This was in lesson 2, right?
Yeah, I think so.
Yeah, it was in lesson 2. Let's see.
Particular district. Randomly select teachers. Okay, so
so it'll be all the way down to section 4.3. So a systematic is where auditors select every kith atom in the population. Okay, so I guess
I would say it's cluster.
Yeah. Yeah, that's right.
All items in a random cluster block. So
Yeah,
they
that
got
makes
all
sense.
the kids in a block of teachers.
Makes sense.
All right, so number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Simple random sample.
I think so too.
Yeah, I agree.
7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. They took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
It's kind of very confusing because I'm thinking it might be for the stratified random sample because we are looking at two sampling groups over here, one for the Republicans and the other for Democrats.
I agree with that too.
Yeah, so stratify. That's what I think.
Yeah,
that is what I also think.
Stratify.
All right, number 8.
So we need this Excel sheet, I think. Yep.
Yep.
Sweet. Oh shit, I forgot to plug my computer in. It doesn't die on me.
Using software, calculate the mean of the amount spent.
Ready.
There we go.
Icon.
I'm gonna wake up. There you go.
Using software. So software in the case is the Excel sheet that we're downloading, I assume.
Yep. Crossroads purchases.
So I just pulled it up. I think let me see. I got 4.771.
1 second. Average this contraction. Yep, that's right.
Okay.
All right.
Are we rounding this thing anyways? I mean, check.
Round to 3.
Round to 3 decimals.
4.771. Sweet. Question number 9. Standard deviation. All right. Let's see. Standard deviation is 1.911.
Okay, I also think I agree. But I think we should, if you do the approximation, it should be 1.912.
That's right. If you round up to 2, that's nothing. That's correct. 9.912. All right. Question number 10. Start by creating a histogram of the amount spent across the purchases, then mark the following. All right, looks like I've got to create a histogram now.
Going back to number 8 real fast. Did you guys say that was 4.771?
Yeah.
Yeah.
Okay. What did you say 9 was?
9 was 912. Wait,
1.912.
no. 1.912. Sorry, that could be really confusing.
How did you calculate standard deviation?
Let me share my screen with you guys real quick.
Okay.
What is that? Oh, dang it. There we go. All right. Can you see my screen?
Yep.
Yes.
So can you guys see this? So the formula is E equals S. That's Excel for standard deviation. And then I selected all the data points. So all the way down there. And then, yeah, and then hit enter. That's what it came to.
1.912. Okay, great.
Okay.
All right, number 10, I'm with you.
Okay, number 10. See. Oh,
Start
we
by
gotta create
a histogram of the amount spent in Crossroads purchases, then mark the following statement as true or false.
So we're just doing it for let's share down. Insert. I think this is the first time it's asked us to create histogram. What the devil is histogram?
Okay, I remember there was a chapter on this. I think it was 5.
So wait, histogram is just the same as a bar chart, right? That kind of sounds like a dumb question.
Yeah.
All right, let's see here.
I think this is, I don't know whether I'm right because I can you see my screen?
Oh, 1 second. Let me
Yeah.
go there.
So
I can't see your screen. Oh, there it is.
this is what I don't know whether I'm right.
So the
Kind of.
can you separate the so there you go. So you see how it's squeezing some of the dollar value together, like the 84 cents and 2.34. So separate that where you have each dollar on its own graph.
I should separate it.
Yes, separate the bars to make sure that each bar represents $1 amount, like each dollar amount. Does that make sense?
Yeah. So you need 85 bars.
Well, I don't. I still.
Well, let's see. How do we change to ascending order?
Ascending order. With the data, then I think that we have to filter the
Let's see. I think I'm doing something wrong here. Let's see.
So
Oh, I hate it that it's saying the Siri thing instead of the dollar value.
because I don't know whether I can do the separation. I try.
One sec. Let's see if I can. I'm working on it. Here. I think I'm gonna do something with this data. I'm gonna take and transpose it and let's see if it'll be able to give me the same thing. I'll just mess with this a little bit. Control C. Down here. Transpose like that. All right, and then use that to do a bar chart and see what happens. Oh. Let's see. Value. Let's see. Okay, let's see. Oh, all right. Okay, I think this should be helpful. I'll share my screen with you guys real quick.
Okay.
I wish I could do this in a 3D, but so oh come on. I got 1,000 screen open. Okay. Share screen. Let me know if you can see my screen, okay? So would this be helpful like this? Where we see the dollar value here and then we can compare the bars across. Like the dollar values are right here.
Okay.
And then we can see like, and series one will be, well, the number one here will be the first data above. And then the last number here will be the last one on the bottom, which makes sense because it's $2.20 for the last one on 86. And then down here it's about $2.20. And then the first, oh dang it, I brought my chart too far. Now let me take it up. I'm trying to go at the top of the oh, these things can be annoying sometimes when there's no shortcut on them. All right, now we're here. So the top bar 2.23. So the first bar is 2.23, and then the last one was $2.20. So it's right there. So from here we can compare the dollar value just right across to see. Does that make sense?
Yes. So I think the question is asking is that if we can start by creating a histogram of the amount spent in crossroad purchases, then mark the following statement as true or false.
Okay, let's see the question. I'll stop sharing my screen. Dang it, where did it go? Okay, there we are. I created a history representing the amount spent across the so didn't we do that? So that's a yes, right?
Yes, I think it's true.
Oh, it was just testing our ability to create history. Oh my God, I can't believe we just, but I'm sorry. That was my fault. I kind of overthought that one.
It's all right. Okay, so we're now on number 11. What is the value of the number that goes in the position marked with an A in the table above?
So this is the volume minus the mean, right? Yeah.
The X is the value minus the sample mean.
Well, sample mean, not just the mean, but sample mean. Okay.
So what is the sample mean over here? Is it a 4?
Let's see.
Where are you finding 4?
I think it's tapestries were placed in the hepatic cylinders of 4 of their seals, named Bodil, Roberta, Larry, and Pearl. The cell temperature at the start of the dive was calculated to be.
Okay. So Bodil. Complete the following table. To the next 4 questions. So we need to go
I think we did one of these in chapter 3. What chapter was that?
Yeah, I'm going through the chapters. I don't know whether it is chapter 3 or.
well, the sample mean. How do we calculate the sample mean?
Let's see.
I think that's just the mean of the entire data set. sample mean is just the samples the mean of the samples.
Yeah, and not the entire data set. That's right.
And our samples are the 4 seals.
Yep.
Is that right?
Yeah, because that's out of the millions of seals. I don't know if there are millions of seals. So yeah, so the 4 is the sample.
So the sample mean is 38.075.
So then A should be 37.1 minus 38.75.
37.91 minus 38.075.
Where did you get the 39?
I'm sorry?
What did you get at 39?
$37.91
Okay.
minus 38.075. I'm seeing number 11 as being 0.165.
I think so too.
All right.
You got a question, Bartholomew?
Yes.
Okay.
So 37.91 minus 38.075. Is that what you used?
Yeah. So in the first number above is, so the formula below deviation from the mean is pretty much minus the standard deviation of the sample mean. So the sample mean that Justin calculated was what we subtracted from the number right there, the value of x.
Okay.
I don't know if that makes sense at all.
I said it's 1 point what?
0.165.
Yeah. And that should be a negative 0.165.
Oh,
right?
That's right. Yeah.
Yeah, that's do we have a deviation in negative?
I'm sorry?
Do we have a standard deviation in negative? Can we have a negative deviation? Because I know that deviation we are talking about from 0 to 1.
Is that what it's calculating? Is the first column deviation from the mean, is that calculating standard deviation?
Okay.
I don't know. I mean, I'm not sure. How do you calculate standard deviation?
The standard deviation, the formula should be in the review. Let's see, what is the value?
The value
The standard deviation should be the mean. No, the sample minus minus the mean divided by wait.
I think that is a score.
Are they asking for B? So I think we'll do the first thing we did for the first one and then square it. Does that make sense?
Yeah.
That's that. I'm just looking at the formula. That's what I'm thinking.
Yeah. And what we're wondering is if on number 11, if we are calculating the right numbers. That's the best I've got. So I've got negative 0.165 for 11 and 0.68 for number 12.
I mean, just looking at the formula there, that sounds right to me. Is it so? It'll be 0.680 then, since they want 3 decimal places.
Round to 3 decimals, so 0.681.
Which is okay.
661.
Number 13, what quantity is equal to the sum of the numbers in the squared deviations column?
The sum of the numbers in the square deviation. Quantity. I have to look at a note on that one. That seems more like a theory question.
What quantity is equal to the sum of the numbers in the squared deviations column?
Deviation. Square deviation.
It's 724.
This is chapter 3. Or lesson 3. I always call it a chapter. I don't know why. Silly me. The answer should be in lesson 3.
Not the mean, the second deviation, the variance. I don't know what the variance is.
Variance. I'll just control find it. Yeah, right there. There we go. The heck is a variance?
We need to go.
Okay. Okay. Let's keep moving forward. If I find it, I'll let you guys know.
Okay.
All right. So on question 13 then.
Yeah.
Question 13.
Okay. What are you on? You said 13?
No. I'm
Oh,
still.
okay. So, sorry, I hate to bring you guys back. So to question 13. According to the instruction from let's divide the sum of the square deviations by n minus, well, by -1. This is ridiculous. Never mind. Let's ignore that. It takes a little of calculator. I don't want us to bring us back. When we're done with everything, maybe we can go back to that one. What's the standard division of these temperature? Oh, I guess we're still on our problem again.
Yeah. So we can calculate that just by running the standard deviation function. That one should be 0.715. And number 15.
No, 15
You calculate the standard deviation of the temperatures.
Yeah, you did.
Yes, I calculated at 0.715.
0.715. Okay.
Standard deviation cannot be negative.
Oh.
Yes, it's true.
Yeah.
Oh, that's right, because they're like absolute value, right?
Yep.
Cool.
Standard deviation can never be negative. Squaring all deviations results in a list of all positive numbers.
Cool.
Squaring a negative number will give you a positive number.
Yeah. In the same study, the researchers placed. We're on 16 now, right?
So do you mean that under certain conditions, the standard deviation can be negative?
No, the standard deviation can be, because the standard deviation is the absolute value. So thinking of a number line, the absolute value will always be in positive. It's never in negative.
Okay. Yeah.
Question number 6. One with the lowest standard deviation. So that would be extradural. Extradural. Are you guys there?
Yeah, man.
Yeah.
So 16 should be the one with the lowest standard deviation, I think.
Question 16?
Yeah, question number 16.
The question is, which location resulted in the most consistent temperature measurement from one cell to another?
Yeah, so if the standard deviation is significantly lower, you will end up having kind of like a straight line across. If it's higher, you will see more like an incline or a decline.
Okay.
What do you guys think?
Measurements. Most consistent standard deviation. I would say the most consistent would be emphasizing standard deviation. I would think it'd be extramural.
If I don't do it, then the warehouse can't ship this shoe, and then they get in trouble, and Amazon could cancel their order. And yeah, I'll be fired if that happens. Are we still on 16, or are we good to move on?
Extradural, I believe that is it.
Yeah.
Okay.
That's one.
Number of hours students spent studying for an exam were recorded. The data is represented by the box plot below. Use this box plot to answer the next two questions. What is the third quartile?
That would be 8.
Yeah. Minimum, first quartile, mean, third quartile, max. Let me just double check that for 1 second. Box plot, 5 numbers, 5. Five number summary, min value, first quartile, mean. Yep, that'd be 8.
Okay. This should be because most of the data fall right around our area. So I'm thinking 60s. What is it, 66 or 60? I get confused with 30, 60, 90, but that's a whole different class on this one.
What percentage of data lies between 4 and 8 hours?
Because of what the curve.
That's referring to the 5 numbers summary.
So
between first quartile and third quartile is the 68%.
So the first, wait, and the first quarter is 4. The second is 6, and the third is 8.
Yes.
So,
right.
So that's, wait, am I getting this backwards? So 66% fall in there. 1 second. Which chapter is this?
Don't look at 66. That's just
sorry.
That's not the answer.
Not 66. Oh, there we go.
I believe the answer is 68%, because if we do the 68, 95, 99.7 rule.
That's what I was trying to quote earlier, and I was saying 30, 60, 90. 68, 95, and 99.
So that's within one standard deviation for 8.6. Yeah, that should be 68% of data is in the first and third quartiles.
Yeah, I think so.
What's in the 95 then?
The 95 is like 1 standard deviation away, so. Wait, what is that question on it, or that was just a question you're asking?
That's a question I asked. If 4 and 8 is the first and third quartile, then where's the 95% data?
Going back to it. 95, I think will be somewhere between what is it? 4 and 10, something at 10. I know, because between 10 and 12 would be 99. Just going back to this chart again.
The chart is there under lesson 4.
Lesson 3, I think. It's in lesson 3, right? I know we did some box wicks. Lesson 3, yeah.
Box plots.
I wonder if there's more whiskers in lesson 4, because lesson 3 just kind of introduced it. A lot is on there. I'll check real quick.
Yeah, box plot is just another representation of a normal distribution.
Okay.
So yeah, that should be 68%.
Okay.
Number 19. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
Oh, the mean is 2.055.
Okay. 0.055.
And then the standard deviation is 0.233.
How did you get a mean?
It's a long calculation, but I'll try to explain it. So when you go back up, oh, I haven't shared my screen. I'm about to start explaining.
Yeah.
Share screen. So you kind of have to visit algebra a little bit, okay?
Okay.
So if you take this and stick it right below this and add both of them and divide the sum of the last number on the side, because -2 with the standard deviation plus 2 standard deviation will cancel each other out, right?
Yes.
Does that make sense?
Yes.
When they cancel each other out, you'll be left with 2 equal 4.11. You divide both sides by the 2 next to the mu to get the standard. I mean, to get the mu. So you take this and put it right below this other formula. Add them both together. This will cancel out with the +2, and then you have 2u. I'm just calling this u. I know it's mu, but 2 mu 4.11. You divide both sides by 2 to get mu by itself, and you'll be left with 2.055.
Okay.
All right.
Thank you.
And then you got the standard deviation.
Yeah, just by subtracting or like deducting, because I put on a number line and then just having a standard deviation, because it even says here, -2 times the standard deviation should give you 1.59, or +2, or 2 times the standard deviation will give you 2.52. So if you take the mu and times our standard deviation I just gave you by 2, it should be equal to 2.52, and the opposite on the other side should be true. That's another way to test the standard deviation I just gave, the 0.233.
Okay.
Estimate around the mean of the measured nitrate concentration. Okay. I'm good with that. So, we're number 21, right?
Number 21 should be the third option, right? Because the third quartile will be 1.59, because that's below the mean, and the fourth quartile will be 2.52. So I'm thinking the third option.
Well, there's only a one first and third quartile. There's no second or fourth.
Okay.
So you mean the first and third quartile?
The first, sorry, first, did I say fourth?
Yeah.
Sorry, first and third quartile. 2 standard deviations south, and then the third quarter is 2 standard deviation on the other hand, not south, but
yeah. Standard deviation is standard deviation is 0.233. So the mean is that, so 1.8. Actually, it would be the fourth one.
It'll be the fourth one?
Yeah. Because we calculated the mean to be 2.055. We calculated the standard deviation to be 0.233. So if you take the mean minus the standard deviation, that gives you 1.823. And if you take the mean plus the standard deviation, that gives you 2.288.
Okay. I'm drawing a box plot right now. .2.
Yeah, I'm pretty certain that the fourth
Okay.
Yeah.
Let's go with that. 23. Oh boy, I only got 3 minutes to be in class. There's still more questions here.
All right, let's go. Now, what is the probability that a randomly selected student will score above 542.3 on the GMAT? Randomly selected student. I should call that the scores on the GMAT. Minimum GMAT score. Above 542. The probability that a randomly selected student will score above 542.3. So we need to find out what the z-score of 542.3 is.
Yeah, I'm looking for my old file right now. Let's see, quiz. Oh, there it is.
Z minus the mean.
So the observed number is
Probability that randomly will score above 540. Well, the mean is 542.3. So we're wondering how much for this, if it's normally distributed, 50%.
And then standard deviation is 120.54, 120.54. And the observed value in this case would be
500, right?
Is it?
No, we're wondering what is the what is the probability that a randomly selected student will score above 542? Well, that's the mean. So anything above 542 would be 50%. So it should be 50%.
Oh, that's what you mean. Okay.
Okay.
Yeah, that makes sense.
Probably around. Yeah. What's the probability that a randomly selected student will score below 600? We've got to do some calculation. So we've got a standard deviation of, what was it? 20.54.
So going back to question 22, would that just be 0.5 or we'll put like 50% because they?
Yeah, I'm not sure. It didn't specify.
I'm a little confused on that one.
Usually it asks for that in percentage, so I would put 50 without any decimal.
Okay.
So we're looking for a z-score. So z equals 600.
So 600. Oh, I was already doing that one earlier. The observed value is 0. I have is 0.479, but calculate and let me know if that matches.
All right. Yes, 0.479. So we plug that into the applet.
Where did you get it, applet? I don't have it open.
I think there's a link to it.
Yeah, I think the first question also.
Oh, okay. Oh, there it is. Thank you.
And so I think number 23 is 0.684.
Okay.
Or 68.
Point.
Well, I'm not sure what it wants the answers in.
Oh, it said below, right?
Yeah, it said
let me go back there. I think
Is
So
it
it should
looking
be
for a
good.
percentage? Is it looking for a decimal?
Oh shoot. Yeah. Oh, the probability is always in point something, I think. So we just copy it. Oh,
Yeah,
and it didn't say round. Oh,
it's a round. So point, I guess 0.684 probability is a probability is between 0 and 1. So decimal it. We're gonna decimal.
yeah, I think that's what I'm gonna put.
So and we're just gonna assume it wants us to round to 3 decimals. So 0.684 is a probability they randomly selected still will score 600 or above.
Oh, we'll just go back to the same app.
Yeah, and just get what it's got there, 0.316.
Yeah, sounds right to me.
And the GMAT score that corresponds to the 10th percentile. Okay.
The 10%. That's like the tiny spaces on the very end, right?
Find the GMAT score that corresponds to the 10th percentile. So what we're gonna do.
There was this is lesson 6, I think. Lesson 6 or 7.
Score that corresponds to the 10th. Okay. Score that corresponds to the 10th percentile. So we're gonna click this. So who above the 10th percentile is going to get above that or above? So
There was a question in one of these. They did it kind of backwards. I'm trying to find the example real quick, but I can't find it. Maybe it'll be in lesson 7.
Okay. In lesson 7, we didn't do anything like percentiles.
I think. Oh, actually.
So I think it's 697. 697 on 25.
Oh, so we're looking for the school. Okay.
The GMAT score.
Okay.
Rounded to the nearest whole number. So what I did was we were looking for any score, for the score that is at the 10th percentile. So 90% of the data is going to be below that. So what I did was go to the probability applet, shade the right side, and set it to 10. And then I took that z-score, 1.282, and multiplied it by the standard deviation, and then added that to the mean.
Okay.
Okay. So that's my best guess. Find the GMAT score that corresponds to the 90th percentile.
Which is
10th percentile. I might have gotten 26 and 25 reversed. Yeah, I did. I got it in reverse. So 697 would go to number 26, and then we have to calculate for 25.
Okay.
697 should go to which one?
So 26.
97 should go to 26.
Okay, so what about the 25?
We got a calculator.
Okay.
Working on it. 1.282 minus times 124. Plus the mean. What is the mean? 42.3. 380. I think 25 is 388.
Hmm?
388, I think, is 25.
Yeah.
Oh, jeez.
27. Find the first quartile of the distribution of GMAT scores. Okay, so the 8% rule. Find the first quartile. So that would be there. So I think to solve this, what we would do is go take the mean of 542.3 minus the standard deviation, 20.54. And that would be 421.76. Nearest whole number, so that'd be 422. I think number 27 is 422.
422.
Yes, 422.
Okay. I'm kind of lost on it, this one. I have to revise this lesson very well.
Okay, so what?
I'm working on the last one right now.
All right.
Number 15.
So to briefly show my screen.
Okay.
Well, I want this over here. So for 27, this is what I did. We want to find the first quartile of the GMAT score. So I went to the applet, and the first quartile is the first distribution.
Yes.
And we're trying to figure out this spot right here where the red line is.
Yeah.
So that z-score is -1. And so what I did was I took the mean minus 1 standard deviation, which is this spot right here. That's 1 standard deviation.
Okay.
Mean minus the standard deviation. And that gave us our GMAT score of 14.76.
Okay.
All right. And then the nearest whole number, which is 422. I mean. So then for finding the third quartile, I believe we would come back here. And the third quartile is the first standard distribution on the positive side. So we would go the mean by 42.3, plus the standard deviation 120.54. Which would be 662.84. The nearest whole number would be 663.
Okay.
And then 29, consider simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample means scores for all such samples? Distribution of sample mean. As I understand it, the mean of the distribution of sample mean is the same as the mean of all the data.
Yes.
Is that right?
Yep.
Yes.
Here's 10th, one decimal.
And that mean was 542.3.
Yep. What is the standard deviation of the distribution of sample mean scores for all such samples? I believe to solve that,
Already there should be 1.856.
1.856. Okay, can you show briefly how you did that?
I'll share my screen real quick. So these are the data. So the number is 15. The value is 600 because we're still on the same value, right?
Yeah.
I suppose.
Does that make sense?
Yeah.
The mean is just, I just copied directly from that. This was the standard deviation for that. So my formula is saying D24, which is minus E24, which is the mean, divided by the standard deviation divided by square root of the number, which is C24. You have 1.5. And our formula is from chapter 7. Dang it, where did it go?
Yeah, that was
Yeah, this right here.
Formula X minus sample mean X, all divided by standard deviation divided by square root n.
Yeah, that's what I did to get that.
Yeah, X minus the mean. Yeah. What do you call that? The U mean? That little U there. You call that the U mean?
You. I always call it U, and then I'm like, wait, that's not a U. That's a something.
Yeah.
Probably that'll be greater than 600. This is what we'll go back to the app, right? With that new that new standard deviation that we got.
Yeah, that the sample mean GMAT score for Nestor S at n equals 50 should be greater than 600. Yeah. So we would take sample mean GMAT score for Nestor S at n the 1.856. So I guess that we would take the mean 542.3 plus times the standard deviation. I think will be greater than 600. Break.
I'm so late for my class.
All right. So you can go if you need to.
Okay. Get here in a sec.
And what's the standard deviation? Samples. 1.85. Not very good at all. Greater than 600. 42.3, 600 times 1,000. 15. Where is that function? Standard deviation 1.856. All right, I'll have an answer in just a second, hopefully. I don't know if it's right, but we'll see.
Oh, so heads up, guys.
Yeah.
27, 28, 30 will have to be reworked.
Really? So did you submit just now?
Yeah, and 22. So 22, 27, 28, and 30. Oh, and
What
yeah,
answer did you get for 30?
30. That was the Z-score that I calculated. I was wrong. It says it's wrong. So I don't know why.
And
I
was
have to look
30
into.
was 31 wrong?
So 31 was 0.030. I just put the Z-score and got the higher end of let me see here. I'm sharing my screen right now. Let me know if you can see it. So I just put it. It's weird because the Z score. Oh, I put my Z score in wrong, I guess. 8.56. Some of the silly things I do sometimes. Instead of 1.881, I put 8.56. Don't ask me how I got that Z score. But yeah, so then I just got the top part right here and it was correct. So right at 0.30. But this should be 1.881. Where did that come from?
Okay. Like what about number 13? Did you have an answer for that?
13, I think so. Oh, 13 was wrong too. I put variance and it was wrong.
What other ones did we get wrong?
That's so 13 was it was total of 20. I got 24 wrong, so I got 7 wrong. So 30, 28, 27, 22. So this one's probably because we're putting it in. Maybe the format was wrong.
Maybe.
20. The heck? And 13. Oh, wait. 11 was off too. I think that's it. Yeah, I
So
think that's it.
11, 13. 18, 22, 24, 27, 28, and 30.
Yeah.
All right.
Cool. See you guys. Good luck. I'm gonna see if
All
I can
right.
sneak into class now.
All right. See you later.
So yeah.
Hey, Bartholomew, I've got to go too. I got to take my kids to school.
Okay. All right. So I'll try to work on it later on. I will not submit it now. I'll try to work on it, and if I get anything, I'll email you guys.
All right. Great. Thank you.
All right. Okay.